Hello, everybody. Today, I am delighted to talk about our work, which is called FADE, Detecting Fake News Articles on the Web. This work has been done by myself, Bahruz Jabiyev from Northeastern University, by Sinan Pehlivanoglu from Brown University, Kaan Onarlioglu from Akamai, and Engin Kirda from Northeastern University. Why is fake news a big problem? We all probably have read many headlines about real effects of fake news in our lives, in human lives. We all have read about how fake news might have played a big role in the outcome of 2016 US elections. We also learned that Facebook was forced to shut down its platform in Sri Lanka after a mob violence, which was caused as a result of fake news. We also learned that hundreds of people died as a result of COVID-19 misinformation. After reading some misinformation online, some of them drank alcohol-based cleaning product, some of them got large quantities of vitamins in the hopes that their disease will be cured. Why is fake news a hard problem? Because fake stories are usually very cheap to create, and that's why they can easily become ubiquitous on the internet. And they can spread very quickly like a land fire through the shares and likes and this type of user interactions in the online media. And we are, as human beings, sadly not very good at identifying fake news, understanding what is fake and what is real. When we look at the prior work on the detection of fake news, we see two main categories of related academic work. The first category is using text-based features like word count, like types of words, pronouns, nouns, verbs, or sentiment analysis like the use of slang or positivity and negativity in the text. These type of features are used to classify news articles in this category of work. The next class of work is building neural networks by training their models on large amounts of fake and real news content. And these models are used for the classification of news articles. We can say that prior work has mainly focused on the characteristics of text, the content of news article, to decide whether it is fake or real. Our approach, FADE, is a little different. We basically automate the research process of a careful newsreader. Careful readers usually search for other sources covering the same story and analyze or check the reputation of those sources to understand whether the given story is true or false. For a given news article, we use this rule. If a news article is a real one, then other trusted and mainstream news sources should have covered the same story. If it's a fake, then either no source covers the same story, no major source, or some fake news sources are publishing or covering the same story. And those fake news articles might also cite other fake sources. How does FADE work? We search for a query article, for the query news article in the search engine. And we filter search results based on text and date similarity to find which of those search results are covering the same story as the query article. After finding those search results, we extract some features, which we will get to in a second. And we does a classification based on these extracted features. Let's see these steps in action. Let's see, our query article is this, and it says Pope Francis found guilty of child trafficking, rape, murder. The first thing we do, we extract the title from this article. The next thing, we extract keywords from this article. And then we do two searches, one for title and one using keywords. In this example, we will see the search with the title. Let's say we get the search results after searching for the title on DuckDuckGo search engine. The first thing we do, we extract dates from articles to measure the date similarity. Now let's say that the publication date of the query article is January 28th of 2018. And we see that most of them have been published at around the same date. Only the last one is from 2017. That one is filtered out. The assumption here is that if a search result is covering the same story as the query article, then it should have been published at around the same date as query article. The next step is to measure the text similarity. Here we find that the first one is the least similar one to the query article, with only about 35% text similarity. Let's say our threshold is 0.4 here, and this 30.51 gets filtered out. Now we are left with 3 search results. We assume that all of the search results are covering the same story as the query article because its date and text content is very similar to the query article. The next thing we do, we group them into buckets based on their text similarity levels. This bucketization will help our classifier to give separate weights to each group, meaning if a search result appears in a high similarity bucket, it'll have more weight in the decision made by the classifier. The next step is to analyze the reputation of sources in each of these buckets. To analyze the reputations, we've got 3 types of reputations. The first type of reputation is trusted source reputation. For that, you're using the list of survey results by Pew Research Center and Reynolds Journalism Institute. The next reputation type is legitimate news source. To decide whether a given news source is legitimate, we're matching it against the list of Alexa News category top 500 sites. Finally, we're using fake news sources list for the fake news source reputation. And this list is from PolitiFact, which is a fact-checking organization, and their list has about 330 fake news sources in it. Then we count the number of trusted, legitimate, and fake sources in each of these buckets. The blue one has 0 trusted, 0 legitimate, 1 fake source in it, and the red bucket has 0 trusted, 0 legitimate, and 2 fake source in it. And then we combine the numbers from each bucket into a feature vector. We've got 6 buckets, each of them spanning 10% similarity range. Above 40, we've got 6 10% range. That's why we've got 6 buckets. And we've got one final feature to add to the feature vector, and it is the number of cited fake news sources. For that, we extract the links from within the article, and we match their sources against the fake news sources list and find that one of them is fake. And we add this feature to the feature vector, and now our feature vector is finalized, and now we can fit that in to our classifier, which is SVM, separate vector machine, and it'll produce such a result saying that it is 20% likely to be real and 80% likely to be fake. We evaluate this classifier. First, to train, we use 5,000 news articles, fake news articles from Kaggle fake news dataset, and 5,000 real news articles from collected news articles from several reputable sources. We collect them ourselves. And for the testing data set, we manually collect 500 fake news articles from fact-checker organizations' websites like Snopes, PoltEffect, and factcheck.org. And for real articles, we manually collect 500 real articles from several reputable sources, all of which we make public in our GitHub page. We achieve 87% of accuracy, 92% of recall, and 84% of precision on our testing data set. We build a prototype as a browser extension for this classifier. Let's say we read this article saying Boris Johnson and Carrie Simons marry in a secret ceremony, and we are wondering if it's a real or fake news article. We can click on any point on this article on the screen. We can do a right click and say, see if it is fake. We will be provided with a result in about 10 seconds, without caching, of course. And this 10 seconds were achieved with a server which has only 4 CPU cores. We believe that if it was a more powerful server, then that 10 seconds will go down, probably down to 4 or 5 seconds. If we had caching, we would get instant results, and our service would be a virus total for news articles, virus total service for news articles. We are also able to explain the result numbers by showing the list of sources which published the story and cited fake sources to give an idea why this is the result to readers. Let's see this in action. Let's say we right-clicked on this article and send it to our browser extension, and our extension said that it is 85% likely to be real and 14% likely to be fake. We can click on see why. When we click on it, we will be taken to a page where we are given reasons for this result. It says that these stories have been found to be published by these and these sources, and all of the sources have been listed here with their links. If it was a fake article, then this page would probably show us something like this. ConservativeDailyPost.com published this story and this source is not reliable. Or we would say this. RedState.com is being cited and this source is not reliable. Alongside the fact that no major source has been found to publish this story. We also deployed Fade extension in real time to see its performance on emerging fake and real articles. Over the period of 10 weeks, every day, we collected emerging fake articles and emerging real articles and ran them against our extension. We found that our extension performed with 86% of accuracy, 91% of recall, and 80% of precision. We achieved almost the same results as our classifier. And this shows that Fade extension can perform in the real world scenarios in real time against emerging fake and real articles. I thank you for your attention, and if you have any questions, please feel free to ask. Thank you.